Do I need to hold it down, or I'm okay to
It's
just?
recording. It's recording.
Just type the
We're good,
keywords
then.
on the screen.
You don't
Kids
write
always
it
help
down.
me with stuff, yeah.
You can
Then
just
we
download
good.
it.
They know better than me.
Yes.
I'm sure they're
It's
right.
recording.
Thank you. Okay, so important ideas that can someone list ideas that we've come up with so far? What are some important things we need to know about adding? Yes. Yes. LCM. What else? Yeah.
Doing the same thing as top and bottom.
What I do to bottom. I do. That is supposed to be capital. What else do you want to remember? Keep it as factors. What about when we're subtracting? What should we do?
Factor the negative.
Yep, distribute the negative. And always, I heard someone say it, always, greatest common, starts with the F, the F, greatest common factor. We want to look for greatest common factors. This will help us simplify. That was horrible. So let's look at this one. Number 1, add the rational expression. What do you already notice? Yes.
There's an x plus 1 and an x minus 1, and then we just cancel each other out. Like, it's not the same. The first part, the denominator, like the first part has an x plus 1 and the second has an x minus 1, and if you add them, they'll just cancel each other out.
It will be the difference of squares. Yeah.
So you just cross them out?
So we cannot cross them out, but they will, when you're multiplying, they will cancel each other out. Yes.
Yeah, x plus 1 is the same thing, so it will be x minus 2, x plus 1, x minus 1.
Yeah, exactly. So we need to multiply something to this side and this side to make them common. So you said we need the x minus 1 and an x minus 2. Do you agree that they now look like common denominators? But what do I have to do?
Don't talk.
Do it to the top. Now what should I do?
Combine the, like, multiply the factors together.
Yes. We're going to multiply this and multiply this. Mhm. Because we multiplied it to the bottom, we're going to multiply it to the top. And then we will add.
Can you show the box where you FOILed the x minus 1 and x plus 2?
Mm-hmm. So using the box, you could do x minus 1 and x plus 2. We get x squared, negative 1x, 2x, negative 2. Now you can combine these when you put them over. So 2 minus 1 would give you 2 minus 1 will give you 1. Thank you. Instead of having to write both denominators down, I put all of the top over the line, and then I just take one of our common denominators and keep it on the bottom. Because we just add the top, right? This will make it easier to not have to keep writing. Okay, now what should I do?
Combine like terms.
Yep, combine like terms. What should my top look
I
like?
think we should factor out the zeros first.
But it might factor different when I add the numbers together.
Yeah.
You have to combine like terms
That's
before
true,
you
actually,
factor.
never mind, it's not bad.
What is my top gonna look like?
No more decisions, yeah, we're fine.
2x squared
You can share the Lego table
Minus
with
one
first
x
love.
minus two.
minus 1x minus 2.
All over the.
What do we need to do? All over this. Should we leave it like this? No. No, because we want to what? We want to factor it. Why are we factoring the top?
See if it cancels out.
To see if anything cancels out, because we want to have this reduced, simplified.
2, negative 2. No.
So we have to see what adds to get the middle
Multiplies to 4.
and multiplies to get
Sorry.
Negative 4.
first times last. What are our two numbers?
2 and negative 2.
That would be 0.
That'll make us 0. Is it not factorable?
Yeah, I can factor.
I'm sure it's not factorable.
So what does that mean? If it's not factorable? It's done, right? Because if the whole point of factoring, like Jacob said, is to see if anything cancels with the bottom, and the top doesn't factor, is anything gonna cancel with the factors on the bottom? Nope, so it's done. Except for excluded values.
Yes, but we want to state our excluded values.
But do you have to state them every single time or only when it asks?
Every single time.
Every single time?
Because it's going to ask every single time.
So x is not negative 1, 1, or 2.
Are we good with excluded values, or does anyone have any questions on how we got? Yes.
So on the denominator in the original question, there's like x minus 1 2 times. Why do we write it 1 time when we like are solving?
That's a good question. So this one, we're just focused on the number itself. We're not graphing it to know any multiplicity or anything like that. So if it's negative 1, you don't have to list it twice. It's already there. What was your question? On which part? On which
No,
part?
just keep going. I just didn't understand what she was asking.
Oh, okay.
Can I clarify? Is that okay?
Yeah.
Just because if one person has the question, I'm sure lots of people do. She was asking, there's multiple x minus 2 factors. So why don't we have to deal with the multiplicity of that factor? And the reason is because it doesn't actually, well, one, we're not, just like Hooper said, we're not graphing it or anything like that, so we don't care about multiplicities if there was one. But the other reason is because it is contained in both fractions, but it's actually only there once in this fraction, which is why it isn't one of the ones that need it, like, the whole point of the common denominator is to have all of it one time at the bottom. Does that make sense? That's actually why it's called least common multiple, because I only multiply in the things I have to. I don't want to multiply things more than once. That's why I don't take it and just multiply each denominator by itself. I only look for the missing pieces. So it's the least one. So it's only actually there one time. Sorry, Hooper. We're going to have to re-record anyway because your screensaver came on.
Yeah, I saw that.
Yeah.
So I'll have to change that.
But now we know.
Maybe we should like stop because those are all my pictures.
Oh, well, but they're so cute.
They are cute.
Cute our kids are.
No.
Aw.
Okay, can I tell a funny story real quick?
Of course, we're not recording.
One time I had that on my computer at home, and there were pictures from when I was having my babies on there, and they started popping up on the screen for everyone to see, and I was like, ah! We need to delete all of those.
No, that's hilarious.
So, let's see here. What time did we get out of class?
10:42.
10:52? Okay, we're good on time. This is a subtraction one, so we're going to do it so we remember all the things we need to know about subtraction, but then I definitely want to go over some of the others. We are going to do number 2. What should I do? Yes.
You have to multiply the x minus 3 to the other side, right? And the denominator is the same.
Yeah. I only have to do the x minus 3 to this side to get the denominator the same. Because like she said, why wouldn't I multiply this side by x plus 5?
It's already there.
So we got it.
Yeah, so we're not going to multiply our denominators together. We're going to find the...
Least common.
Yeah. What do I need to do because it is subtracting?
7x minus 21. Oh, wait.
Try that again.
You have to do the negative 7.
Exactly. We need to make sure that this negative stays with the 7. I hope this one lets us factor the top.
It won't because it's not quadratic.
Oh, I thought there was a square. Dang it.
Do you want me to
But
look
it might be a GCF.
Yeah, it might be.
I'll look in the notes and see if there's one in the notes that makes you factor the top.
Okay. What does this look like all terms combined?
Negative 6x plus 21.
Should we do something to the top? Find the GCF. Which is?
Negative 6.
Negative 6.
Negative 6.
Is there GCF?
Can anything cancel out? No. So this is the end of the subtraction. But now what do I need?
Oh, excluded zeros.
Excluded values.
And those would be negative 5 and 3, right?
Negative 5 and 3. Any questions on any of those steps?
Is this it? Is that like
Yours practice.
We're going to practice. I want to go over the last 2. So turn to G.
Will you stop the recording and I'm sorry?